afternoon, and today I'm going to talk basically at how we started to use Blackfire and Trivago, why, and basically what we achieve with this. It's basically what we are going to cover. Who am I? Basically, I'm a software engineer. I'm working on the performance team on Trivago. Outside of Trivago, I'm an Apache Notch committer and PMC. I'm also a member of the Apache Foundation, and I'm really passionate about search, metrics, logs, and performance. If we look at Trivago, Trivago's mission is to provide the user with the ideal hotel at the lowest price. And although we are really based on Düsseldorf, so in Germany, we are a global business. This means that we have 55 platforms, different platforms for different countries. This is distributed worldwide. We have 4 data centers around the world. Our system produces around 1 terabyte of logs per day. And right now, at this moment, our response time is around 200 milliseconds, taking into account only the backend time. To give you an idea of the scale, let's say that this is the popularity or the interest of, over time, of the term hotel in Paris in Google, so taken from Google Trends. If to this graph we add the term Trivago, this blue line becomes this, and the red line is actually Trivago. So taking a look at this graph, yes, we get a lot of traffic, and although it's really, really important that our website really performs well. If we take a look at the technical stack, Trivago is mainly a PHP application with a Symfony core, although we have some services for prices and other stuff written in different language, and for the front end, we use actually the normal stuff, HTML, CSS, and JavaScript. We also use another technologies. We use different frameworks or different languages for other purposes, like Jenkins for CI, Bitbucket and Jira for organizing the work, and stuff like that. Our application is always under really heavy development. This means that we have roughly 200 commits per day, and in any given moment in time, we have more than 100 active A/B testing, which we call C-test, in our website. So yeah, it's a really big application. Like I mentioned before, I work for the performance team. If we actually go to with the current buzzwords, this performance team is more like observability team, kind of, if we use the buzzwords. And the mission of this thing is essentially make Trivago faster and spread the culture of performance around by providing feedback to the developers as soon as possible about the impact that their changes is having or is going to have on the application. So this is the core demand for our team, to provide feedback as soon as possible. We don't only do performance in PHP, like we said, we are kind of the observability team. So we provide support to the entire company in these things, Grafana, Prometheus, and InfluxDB for collecting metrics, which we are going to also see a bit of that. We use Blackfire for performance on PHP, and we use the ELK stack for logging. Now, like we mentioned before, Trivago, it's a business. Our mission is to provide the user with the ideal hotel. So we are not a performance company. We don't want to build our tooling unless it's really, really necessary. And yet, performance is really, really critical for us. So we need our site to perform really well. That's why we decided to use Blackfire. How many people in the audience are familiar with Blackfire? A lot of hands. That's good, so I can make this explanation actually short. So, in essence, Blackfire is a performance management solution. This means that it's not only a profiler that you plug into your code to get a view of what is happening in that particular moment in time, but it provides you with a suite of other features, like notifications, integration with your CI pipeline in a way, especially if you're using GitHub. It's really easy to use, provides a really easy to use UI, so it's not something that you need to explain to the developers how to use. You show them once how they can run their own profile, and they can do this on their own, so it's really easy to use. And because it's a platform, we get different notifications and integrations. More than this, it provides a really easy to use syntax for writing tests. These tests we can, or thanks to the features that they provide, You can grab these tests in different scenarios, and in tests that you have written in a really simple definition. And you can write these type of tests or assertions over the different metrics and dimensions that they provide. This means that you can look at your application from different points of view, like from the response time, or from the CPU usage, or from the memory or network traffic, which is really, it's a really awesome tool. If we do a bit of history, back in 2016, trivago managed to conquer all the low-hanging fruits for performance. This meant upgrading to PHP 7. We started to use ESI plus Varnish. So it's something that we have in common with the keynote this morning. And we started to use highest CPU servers with a better CPU, which actually for PHP is really, really good. So after we did all of this, we are now using PHP 7.2 in the moment, but at the time we upgraded to PHP 7, which was quite new. So after of this, even without using Blackfire, we had something like this. Can you guess where we started using Blackfire in that graph? I think it's pretty obvious. The problem is that before we started using Blackfire and keeping a constant tab on the performance of the application, we had really a seasonality wave or the response time. That means that that part of the graph that you see that is going down is the optimizations that we did for the summer peak, which for trivago is the highest traffic of the year, because a lot of people book different hotels for going in holidays or to travel. But after that season was done, or after summer was done, performance was not a core thing to worry about anymore. So people started to don't pay attention to performance or to the response time of the website. That meant that really quickly it would really increase until the next year when the next time to optimize was upon us. So when we started to use Blackfire, you can see that we actually not managed to keep the optimizations that we want, that we did the last time, under control, and now it's roughly stable. It's not the same response time all the time because, of course, we introduce changes, but it's kind of stable. How does the current setup look like for us? So first of all, let's say that for PHP, for using Blackfire, you actually need two things: a PHP extension that is installed on the web servers, and an agent that manages the communication between that extension and the Blackfire servers. And then you can view the results on the UI. For us, this meant that we actually, because we are using SaltStack for configuration management, we actually have two single independent roles in our configuration management, which is SaltStack, which is the Blackfire agent and the Blackfire prof. All the configuration that we need to do, we actually try to put on the Blackfire agent, which is a single binary that is doing this communication with the Blackfire servers. But the Blackfire prof only knows about the endpoint that needs to talk to. And this endpoint changes depending on the environment. If it's a stage, it will go to talk to one agent. If it's production, it will talk to a different agent. This allows us to have a total independence between both environments. I mean, we can do changes on each of the environments without a lot of problems. We can do change on the configuration of the agent without needing to touch the web servers. So we are talking about a lot of web servers around spread in 4 data centers. So every tiny configuration change that we do there actually has an impact, and it takes some time to roll out. And of course, we can keep the configuration on the web servers at the minimum. The conclusion of this is that every server on the company can have Blackfire provision in a few minutes. And for us, it's really important because even if it's not the main application and someone needs to actually check the performance of that application, they can do it. They can add this role to the configuration management, run a command, and in a few minutes, everything will be in place for them, even if that person of that server or application never, ever used Blackfire before. So let's talk a bit about Blackfire in our workflow. Okay. Like I mentioned before, Blackfire is a platform. It's not only one single profiler. And it does offer a lot of integrations. For our particular case, it was not all the integrations that we needed. For instance, they do not offer integration with Bitbucket servers, which is what we use for hosting our code. So for that, there was no official integration. For Jenkins, they mentioned in the documentation that you can use the webhook that they offer for the enterprise users to actually trigger the builds from your CI, which is really nice. For InfluxDB, there was no official integration as well. And for the PR-based workflow, for us, was no integration because of Bitbucket server, but if you're using GitHub, you can basically pull it off without a lot of changes. Due to this, and the mix between features that Blackfire offers and features that we actually needed, we decided to write a bit of tooling, which is called Blackfire Proxy. And our final workflow for the developers looks a bit like this. Every time that the pull request gets merged into the Bitbucket server, it will be picked up by Jenkins. We will deploy that into one of our stage servers, plus one server that we use only for profiling, because it really helps to reduce the noise that we get from the measurements. And once that deployment is done, it will launch a Blackfire build. This build will run all the scenarios that are configured, and they are hosted actually on the code of the application, and it will post updates back to Blackfire proxy, which we have configured as an endpoint. This Blackfire proxy on the top right, which is the little, small, really small application written in Go, will translate whatever Blackfire is sending back to the server into something that we can put as a feedback into the pull request. We also get notification in case of phase builds into Slack, and that is done directly by Blackfire. And we also send the metrics back to InfluxDB for long-term storage. From a developer point of view, this workflow, which is how things work internally, but they don't need to know, it looks more like this. Once the pull request is done, or when the build for the pull request is done, Blackfire proxy will update the pull request and in something that in Bitbucket is called batches, build batches. And basically it's like a toggle, a yes, no, or in progress feature that they have that it says this testing or this feature is running, it's done, or it failed. With this, you can actually control if the pull request is able to be merged or not if it failed the performance testing. At the moment, what we decided is that we don't prevent the developers from merging features, but we add a comment similar to the one that you can see below in the lower part of the screen to the pull request. Adding this comment to the pull request has proven to us really, really useful, and it's mainly because everyone involved on that pull request will get this notification and they can take a look. This involves the developers that actually wrote the code, so it's good to them to know that they are making the application slower, or they are not doing an impact in performance, but also the QA teams. And once the QA teams receive a notification, they actually are a bit more hesitant about deploying this to production or not. And they usually check with us and check with the developers, which is, in the end, what we want. I mean, it's, like we mentioned before, it's spreading the culture of performance. Of course, we provide more notification, more feedback to the user, which includes a notification to Slack in case that the build failed to one specific Slack channel, and then people can subscribe to this and they can take a look at when or how often a pull request or a change is failing is failing from the performance point of view. We also send the notifications back to InfluxDB for long-term storage. Why we do this? Because Blackfire only offers 90 days, if I'm not mistaken, of retention of the data. So you can see the profiles and you have the metrics, but one, you don't have a graph like this, although they added something like that last year. And you have it in some of the environments, but it's not the same because here we have one data point for every build run, for every test executed. What they offer is aggregation daily, if I don't remember incorrectly. So with a graph like this, it's really easy to note or to know when one application is actually having problems on when something happened that actually made the application slower. We also added one more feature to this tooling for us, which is the ability to trigger builds on demand. They offer this for a couple of tools, like for service that you can integrate Blackfire with, but specifically for Grafana, it's something that we actually wanted. This means that we have an alert, actually on the graph that is on the front, you can kind of see it. In this graph, we have the response time over time for all applications for a span of time, in this case, 7 days. If at any given moment the response times goes above a given threshold for more than 3 minutes, we actually trigger one build. This allows something really interesting. The application is slow in this particular moment in time. Why? Could be that there is a database problem, a network connectivity issue, or it's something that could be fixed in a couple of minutes, and then you will never know. This is not caused by actually the code itself, although perhaps under certain circumstances could be, but thanks to this integration, we can actually know what was happening in this particular point in time when the application was slow for the clients. And that's, for us, is really valuable. In the graph, you can see actually the Blackfire, that we configured just Blackfire proxy as an endpoint or as a notification channel in Grafana. And with that, we trigger the build. Now, let's talk a bit about a couple of examples about where or when Blackfire has been useful for us in 2 different cases. For instance, if we take a look at this, we're actually seeing different dimensions of the application. I'm not sure if it can be read. Like, okay, from the top left to the bottom, we have wall time, which is basically the overall response time. We have CPU, memory consumption in the second row, and we have I/O wait time, and the memory usage. It's pretty easy to see that the application in this point became slower. I mean, it's what we get on the first portion of the graph. But why? In this case, using Grafana, we can see that it's something that actually it was fetching more data from the network. It was actually doing more stuff with that data. I mean, it's like Tobias mentioned this morning, if you fetch more data, you have more code that is going to execute the same thing more time. So something clear happened, and we were kind of a bit scared. When we actually go take this and let's see what is happening, what the code is executing on Blackfire, then we get something like this. On the left is the call graph on the memory case, and it's really easy to spot what it's actually doing. I mean, we are reading more data from the network, and then decoding that data, which is in JSON, is actually slower. If we take a look to the timeline on the right, which is one of the cool features of Blackfire, then you can see that it's actually like, it's one spike. The application is performing normally. We actually load 2 megabytes, 1 megabyte of data over the network, and then the memory usage goes like poops. It jumps. And this is making your application slower. In this particular view, it's really useful to see the call graph or see the timeline and go to the exact method, function, or class that is making the application slower. Since this is annotated with the actual pull request number or the commit ID, which we also use, that introduced the change, it's really valuable to know who did the change, who merged it, and then go to the developer and say, okay, you have a problem, look at this. There is something clearly happening. What can we do? Is this expected? Is not expected? It's something that we can avoid. Should we cache it? What should we do? And this is really important for us. Our team is not actually responsible of implementing all the changes. I mean, we are not responsible for fixing the code that the other developers write. And we don't do this because we are not that familiar with the application. We know the application, but we don't know what they are coding. So we actually provide is the tools and a bit of the understanding of how the application is becoming slower or why, and then the developers, thanks to the communication, they can fix that. But it's not only about fixing bugs. At one point, we set a couple of developers, and we say, okay, let's look at our application and see why it's slow. Like we mentioned before, in 2016, we actually caught a lot of the low-hanging fruits. This means that right now, we are not going to find one particular part of the code that it will magically give us 50% improvement in the response time, because we already tackled all of these big bottlenecks in our application. So we said, let's do it. We said with a couple of developers that they know very well the application. We run one profile, and we say, okay, from this call graph for this timeline, what can we optimize? At some point, we realize, okay, the SEO module, which is something like that we have embedded in the footer of the application, is taking a lot of time. It's taking 30 milliseconds on the stage server, and it's being executed every single time for every single request. Is this needed? Is something that is changing? And then we have the magical realization that we should cache that. Of course, caching helps. You run the request once, you get the data, and you cache it. The next time, you avoid the computation. So someone wrote a ticket into our Jira that says, the content of the SEO module doesn't change often, so we should cache the tweak output in main cache. This saves the tweaks translations calls, which surprisingly, they are slow. So one thing is that we use Blackfire to actually find a problem, or to actually find an opportunity for improvement. It's not a problem because the application is running still with 200 milliseconds, but it's something that we can improve, and we can make the site faster for certain users. And of course, we also used Blackfire at the end when this was deployed to production or to the stage to actually check. In this case, it was not a lot. It was a 5% improvement overall, a bit more on network traffic because we are not caching that network. We are not fetching the data to do this, and we are caching everything compressed in main cache, and the same for network traffic. And this is a bit, I will say, the magical part. Is how you talk or you work with your developers to solve performance issues. Of course, the developers need to build features, because features is what attract users. And this is the main focus. So it's really, although in a perfect world, the developer should be always worried about performance or about the response time of the website, it's not something that is going to happen always. So having like a third eye looking all the time at the performance, and when something gets worse saying, hey, we need to take a look, is really, really useful. It's priceless, I will say. So when we deployed this into production, it looked a bit like this. That drop over there that is highlighted is basically when we released to production, so we got like a 5% improvement. You can see on the blue-greenish light how that actually behaved over time. And it was not something that made the application suddenly the fastest application in the world, but it works. Conclusions. Okay. Basically, the introduction of Blackfire for us allowed us to detect performance bottlenecks before they are deployed to production. And this is something very valuable. Because what will happen in the previous, before using this, that the application or the pull request with a big problem that nobody noticed will be deployed. After it will be deployed, we will see the next day or in a few hours that the application actually in the monitoring became slower. But this is because someone needs to be looking at the graphs, and it's not always the case. Also, it allowed us to enforce a backend performance budget to stop performance degradation over time. I will say that the combination of Blackfire, which is a really, really nice tool, with the performance degradation, with the performance budget, is like the magical solution to stop performance degradation. Because if not, it's always going to be the case that someone is going to make one change that they forgot something to cache that is going to affect your users. And then you actually need to wait until someone notices that this is happening to fix, even if it's as simple as setting a flag so that the query is cached or something like that. It also provides or allowed us to offer to our developers a common platform for PHP developers to discuss performance-related issues. It's not the same as you say in one graph, let's say on this. Hey, the application is becoming slower. If it was the opposite case, sorry. It's not the same thing because nobody knows what is happening inside the application with certainty, especially not in an application that is this big, to actually know every possible combination that is causing this. With Blackfire, we have like one platform that we can sit with the developer and say, okay, the change that you did, it's actually hurting the performance of the application. And it's doing so because of this line of code or this function or this class. It's slower for some reason. Now we need to figure it out. It also provides an easy syntax for writing and understanding tests. If you take a look at the documentation, the syntax to write in performance tests is like it's a YAML file, and it's something that you don't need to be a developer to know or to understand what it's doing. Perhaps you need to understand a bit, I would say, the question about why they talk about metrics and dimensions, but that is something that is, once you read the documentation or you take a closer look, it's really easy, and for the most part, it's not really critical. This particular case about the syntax is something that, for instance, the QA team or anyone that is not familiar with the application, even the onboarding of a new developer, they can take a look and understand that we have a 5-second threshold for this, or a 2-second threshold, or a 1-second threshold for the response time, and that the home page of the application cannot use more than 5 megabytes of RAM, or whatever is the same value for you. Related to this is that you need to come up with a sensible value. So in our experience, it's something that if the tooling that we put around Blackfire is basically triggering an alarm, with every change that the developer do, developers lose confidence because you are getting a lot of false alerts. You are basically creating a ton of work for some people that they are not, if it's not real. Could be that it's not real. So we actually, in our case, we decided for certain thresholds that allow us to detect problems, but for most of the stuff, it will work. All of this, in conclusion, basically allowed us to have something like this. This is I mean, in the keynote this morning, Tobias was talking about 2 milliseconds application and production, and that is great. In our case, it's not 2 milliseconds, it's 10 times that, but yeah. And for some people, 200 milliseconds can sound like, or will sound like you're crazy, that it's slow. Our application does a lot of things, and to put a bit of context into 200 milliseconds, we can take a look here. This is gathered from the clocks data, so it's the data that Google Chrome is basically, or Google is collecting about certain sites, and we are putting this in comparison with our competitors. So you can see how we actually became faster over time. This doesn't go all the way back, but you can see it. And we can see the comparison with Booking.com, Expedia.com, and with Airbnb. So yeah, it's a bit of context. To summarize, you always need, as always with performance, you need to measure, analyze, and improve. And Blackfire is a great tooling for the first two things that you need to do. It's a great tool for actually measuring. It's really good for analyzing using the call graph view or the timeline view. And okay, it cannot write the code for you, or it cannot fix the code for you, so you will need to improve. You need to do a bit of coding, or the developer needs to, but it really will help you with the first two things. If you want to know a bit more about this, and some stuff that we actually have done after we finished this, you can read these 2 articles in our TED blog. The first is basically what I covered in the presentation, and the second one is what we did a bit more after this. I mentioned at the beginning that we only do the profiling once the pull request is merged, because Blackfire needs the code deployed in a web server. Because we are using Nomad for orchestration in our app in Trivago internally, we actually came up with a concept, or a colleague of mine, Frank, became to the concept that we can actually deploy each independent pull request to this orchestration, and then, running as a container, we can run certain profiling. We cannot actually run a build, like the technical build that Blackfire offers, because the host name or the DNS name that we get for this page is not deployed outside Trivago. It's not accessible from outside Trivago. But at least we can do one thing, which is running a single profile and getting the metrics. So for every commit to every pull request in Trivago, there will be one notification or one comment in that particular pull request that will say how much memory, how much seconds or milliseconds took the page to load. And the rest of the list, right now we are only doing memory and response time, but we also have network traffic and stuff like that. So, yeah, that's all. Thank you very much. If you have any questions.